so now we're going to look at the angles in a circle. And remember, we talked about multiple things with angles, all right? When we look at angles in a circle, there's only 3 here, but we've got multiple types of angles. And those angles, how those angles are, just depends on where they are located in the circle, inside, outside, on the circle. This first angle here is what we call an inscribed angle. And that is what we call on the circle. The vertex is on the circle. Anytime there is a vertex on the circle, the angle is half the arc. So if the arc is 95, the angle is 95 divided by 2, which is 47.5. So this angle is 47.5 degrees. It is half of the arc. The angle is always half of the arc if it's on the circle. Okay? The second one, these are interior angles, and they're not central, so they're not the same as the arc. And what do you notice about these? Those are what we call vertical. So they're both going to be the same. Whatever one is, the other one's going to be. So this is where we use the bow tie. Okay? We've got 2 angles there. We're going to make a bow tie. This arc and this arc. And if you go across here and you use this line and this line, there's your bow tie. Okay? This arc is 175 and that's 53. Now the way you find the measures of the interior angles that are not in the center is you add and divide by 2. You add and divide by 2. So I'm going to take 175 plus 53 and divide by 2. So I get 228 divided by 2, which is 114 degrees. So that means that both of these guys are 114. That one and V are both 114 because they are vertical, which makes them the same. So that's how you find that one. Now if you look at 58, 58 is located, the angle is located on the exterior or the outside of the circle. So this is an exterior angle. Okay? For the exterior angle, instead of adding the arcs and dividing by 2, you subtract. So this arc minus this arc divided by 2 gives you the angle. Well, 130 minus the question mark, we don't know what that is, divided by 2 is going to give me 62. Well, I plug in what I have and solve for what I need. That's basically what I always say. So I'm going to put the 62 over 1 to create a proportion. So here we go again with proportions. Cross multiply. 2 times 62 is 128. 1 times 130 minus question mark is 130 minus, we're just going to call it x. X. I'm going to take the 130 and move it over. So negative x equals negative 2. So x is 2. Okay? So the arc is 2 is what we're in it. Question mark is what we're getting here. So I want to make sure that I have it right. Okay? We have 62 degrees. 130 minus the question mark divided by 2 equals 62. So if I get 2 times 62 is 124. My bad. There's the error. Good job. So I'm going to fix that. That's a mistake. I was wondering why it wasn't coming out right. So negative x equals negative 6, which means x is 6. Sorry about that. So if I do 130 minus 6, I get 124, and half of that is 62. I apologize, but we fixed it. So now let's look at some tangents. Tangents always make a 90-degree angle when they intersect a radius. Remember, that's your point of tangency, that's the tangent. A tangent and a radius always make a 90-degree angle, so that's a right angle, which means we have a right triangle, and we're trying to find the hypotenuse now. So 12 squared plus 16 squared equals x squared, or c squared, whatever you want to call it. 144 plus 256 equals x squared. 400 equals x squared. And when I square root both sides, x is 20. Again, I know that's a right angle because that's a radius and a tangent. So let's look at 60. 60, when you have two tangents that connect to a circle and go to the same exterior point, they're congruent. So 23 is the same length as 2x minus 5. So 23 and 2x minus 5 have to be the same because they're two tangents that go to the same circle from the same exterior point. I'm going to add the 5. So 28 equals 2x. Again, here's just algebra. Divide by 2 and x is 14. Okay. Again, just setting the tangents equal. Now, let's look at, let's see here, the next one. Okay. These are all tangents, and these are all points of tangency. Do you see that? All of these lines only touch that circle once. So by rule, if this is 10.5, this is 10.5. This guy and this guy are the same. Those are two tangents that come from the same exterior point. Okay. This guy and this guy are the same. So if that's 11.2, this piece right here is also 11.2. Okay. And then this guy and this guy are the same. Well, what is the whole side? The whole side is 23.2. But what part of that is not included over here? The 11.2. 23.2 is the whole line, or the whole segment. 11.2 is just that piece. So I'm going to do 23.2 minus 11.2, and I get 12. So that means this guy is 12, and that also means this guy is 12. These two are the same, and that's all you have to do for the tangents. Okay. And to finish up the circles, yay! To finish up the circles, we will look at the segments. And we talked about these a little bit in class today, the special segments. Man, we're getting close. We're in the 60s. These are two secants. Now, do you remember what we talked about with secants? Whole times outside equals whole times outside. If you remember, we talked about that. So, what's the whole thing here? The whole thing is 5 plus 3, so the whole thing is 8. What's just the outside piece? 3, right? Did we see that? Good. I hope you can, because you can't talk to me. What's the whole tangent here? Okay. Or sorry, this whole secant here. Sorry about that. Whole secant. 4 plus x, right? And what is the outside piece only? 4. So that is what you solve. Okay? 8 times 3 is 24. Again, I have whole times outside equals whole times outside. Then I distribute. 4 times 4 is 16 plus 4x. I'm going to subtract 16 from both sides, and I get 8 equals 4x. And I'm going to divide both sides by 4. So x is equal to 2. Okay. So now let's look at 63. These are two chords. Those are two chords. Chords are piece times piece equals piece times piece. Okay? So let's look at this chord. What's the first piece? 4x plus 2. What's the second piece? 8. And let's look at the other chord. Let's do Christmas colors. What's this piece? 4x. And what's this piece? 9. Piece times piece equals piece times piece. Piece. Okay, so what we're going to do now is multiply out. So I have 8 times 4x, which is 32x, plus 16, because I distributed 8 times 4x and 8 times 2. 4x times 9 is 36x. I'm going to subtract the 32x from both sides. Boink. I'll come up here. That leaves me 16 on this side, and 36x minus 32x is 4x. I divide by 4, and x is 4. And if you check it and plug it in, 4 times 4 is 16 plus 2 is 18. 18 times 8 is 144. If I plug in the 4 here, I have 4 times 4, which is 16. 9 times 16 is 144. So they're equal. All right, let's do the last one for this particular video. This one's getting a little bit long. Here I have a secant and a tangent. Okay? Now with a secant and a tangent, remember a secant is always what? Whole times outside. But a tangent, if you notice, whole and outside are the same. Whole and outside are the same. So the tangent is just the tangent squared, because 6 is whole and 6 is outside. So let's multiply this. What's the whole secant? 4 plus x, right? So I've got 4 plus x. And what's just the outside part of that secant? 4. What's the tangent? 6. And remember, it's 6 and 6, so it's 6 squared. Okay? Because the 6 is whole and the 6 is outside. So I'm going to distribute now. 4 times 4 is 16. 4 times x is 4x equals 36. I'm going to subtract 16 from both sides. So 4x equals 20. Divide both sides by 4. X is equal to 5. And that's how you work out the circles.